All right, my name is Hemant Chaskar from Airtime. This presentation is going to be about wireless security and WIPS in particular. We all know the background. Everyone has been following this spat between FCC and Marriott, which started with the fine being imposed, followed by there was a petition from the Lodging Association to FCC, asking them to allow them to block MiFi devices for security and reliability, as they call it. And more recently, there has been a warning kind of turning that down, saying that you cannot block MiFi devices in public congregation areas. So kind of the guidance from the regulators stopped there. And up until this point, several other cases of containment remain unaddressed, right? And that's what the reason for a lot of confusion. Now, I will let them do their work on providing the guidance. And really what I'm going to do here is talk about WIPS on this backdrop. And I'm going to talk engineering, network engineering and security engineering. And pretty obvious thing, but let me restate that I'm not a regulatory authority, right? So look at it as an engineering and a security design presentation. So the first point kind of I want to make is brute force is not equal to security, right? So if you look at what happened in this spat, any visitors would come into the area like this, they would detect an AP, okay, the AP does not match my managed AP MAC, and they would contain it. That's what it seems from reading all this documentation. Now, this is not the way to do security. That's the first point I want to make. And if this is not the right way, what is the right way? And let me kind of have some fun here. So I think the right way is what I call finesse of conscious containment, not the brute. And what does this mean, right? What does the finesse mean? And when you're doing security, what you should be looking at is not harming legitimate users, like those MiFi users who are using MiFi for their own connections, right? You shouldn't be causing airtime wastage when you're doing this kind of containment for security. And if you're looking at large networks, particularly large distributed networks, human intervention is not possible to attend to every security event. So you need automation. And all that you're doing without violating the spirit and civic sense of use of unlicensed spectrum, right? So that's really I call it finesse of conscious containment. And what are some golden rules for that? And if I have to go down to like golden rules, there are really 3 I can come up with. So number 1, only contain the devices that you control, okay? The MiFi device that somebody brings into this conference room is not the device that this hotel controls, okay? So control only the devices that you control. Confirm violation before containment. Just entry into an airspace is not a reason to contain someone, okay? Just entry into your airspace doesn't mean that there is a security violation. And then do containment surgically. So what I will do is just apply these rules, golden rules, to client containment and AP containment and see how they work out, right? So when you talk about client containment, what it means is blocking a specific client from connecting to AP, not blocking the entire AP. That when you contain a client, you don't contain other clients connected to that same AP. So that's what client containment means. And what are the clients that you control? In an enterprise setting, it will be the clients, the enterprise assigned clients, right? Laptops, tablets, those are the things that you control. If you're talking about the BYOD or guest kind of situations, you don't control them until they connect to your network. And if you want to contain them after they connect to your network, I recommend using some kind of opt-in messaging on these onboarding portals to let them know that they will be contained from going to honeypots. And if they don't opt in, don't contain them, okay? So that's the way to kind of handle that issue for onboarded clients, in my mind. Now, as I said, what is a confirmed violation? Confirmed violation occurs when an enterprise client goes out and connects to an honeypot or a hotspot. Until it actually connects, there is no violation, right? So first of all, you have to wait for that to happen. And once that happens, then you can contain only that connection. Do not contain other clients connected to those honeypots, hotspots, or ad hoc networks. They are not the clients that you control, okay? So this is similar to saying that I cannot stop, supermarkets from selling sugar candies, but can I stop my child from reaching for them? That's the logic here, okay? You don't stop other kids reaching for them. Let their guardians handle that. And when you kind of do the containment, this is all-out DOS attack is not the way to do containment, okay? It can be very surgical. It can be feedback-based. You watch the connection and do well-timed deauths. Don't just do a deauth shower or a deauth broadcast, okay? You cannot do broadcast because you are just containing one client. And when you do that, actually I did some measurements. So here what I have done is I'm letting kind of between 1 and 10 clients constantly connect to a single AP, which I want to contain. And I'm basically not allowing those clients to go anywhere else. So this is one SSID profile where they're trying to go, and there are some other SSID profiles in the clients, but there are no APs like that, right? So they get contained, but they have to come back to the same AP. So I simulated kind of a, not simulated, actual measurement, condition, worst case condition if you want to call it. And as you see, if you do well-timed feedback-based deauths, not the DOS attacks on clients, right? You can limit kind of this to 1 to 2%, even up to 10 simultaneous connection, the airtime wastage. So that's what I call, surgical containment. Apply that to that AP, and blocking an AP is different from blocking a client. When you block an AP, you are not allowing any client to connect to that AP. This is different from what we just saw, right? This is different from a honeypot case. So when does this arise? It could be, your managed enterprise APs, which are misconfigured, so you do not want clients to connect to them, or what we call as rogue APs, which in my definition is an unmanaged AP that is physically connected to your wired network, okay? It's not an AP that is just present in your airspace. It is an AP that is physically connected, so it's on your property, and that's my definition of you being controlling it, because you can take a machete and cut that Ethernet cable, right? So that's my definition. And then confirm violation here means that you have to ensure that, confirm that AP is physically connected, right? Not just present. Again, surgical containment of using wireless deauths, the same logic works. Actually, the airtime consumption will be lower here because you can use like a base of broadcast deauths, which apply to all clients, and then only do those time unicast deauths to aggressive set of clients, okay? So I don't have time to show those numbers here, but the numbers for AP containment will be lesser than individual client containments, right? For AP containment, there are use cases where there is no honeypot issue, but a lot of rogue AP compliance issues. And with my definition of rogue AP, the AP that is physically connected, right? You also have another option here, which is to do wire-side containment. And this will get you around the FCC issue altogether because you are not containing anything in the wireless. And to do that, and there are various options like ARP targeting, which kind of kills the connections through those rogue APs on wire by doing some ARP manipulation, or you can go for switch port blocking, right? And there are pros and cons of each of them that you need to be aware of. So that's basically brings me to my last slide. I don't want to wait into the next presentation because I'm not a jammer, right? I'm a conscious containment guy, and that's why I finished 30 seconds earlier. But that's basically the summary of what I wanted to say. Thank you.